Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to all of our new and the regular attendees to our webinar, Smart Monte Carlo. For those of you who are attending for the first time, my name is Michael Trumper. I'm one of the principals here at the Untitled Institute and have been working in the area of project risk management and software development for almost 20 years. This webinar is meant as an introduction for people new to Monte Carlo simulation and looking for some guidance on how to improve their process. Monte Carlo schedule risk analysis, project risk analysis, is a powerful technique that allows you to generate realistic, risk-adjusted costs and schedules that improve your ability to deliver value on time and budget. However, delivering these results requires some preparation and an understanding of the process. In this webinar, we'll provide an overview of the five simple steps to improve the accuracy and efficiency of Monte Carlo schedule analysis, risk analysis, using examples in risky project software by the Untitled Institute. So just before we start, you should have a pane at the top, on the top hand right, where you can select how you want to listen to the webinar. I always recommended that if you have a computer mic and speakers, you use that. For the VoIP, it tends to be a bit higher quality. There is a questions pane. Now that questions pane, if you have questions regarding the quality of the presentation in terms of if you can't hear something or you can't see something, please put it in. We will try and answer that right away or resolve that right away. Other than that, any questions that come in, we will have a time at the end of the webinar just to review those, and I will answer those in the order that they've come in. We are going to be recording the webinar, and it will be up on our site to download if you want to take a look at it, share it with anyone. It'll be up on our site within 48 hours. So we're going to go through some slides at first before we go into the software, but we'll show you what we're going to be looking at, and then we'll show you how it works in the software. Monte Carlo simulation requires you to run hundreds or thousands of varying models of your schedule. So each iteration is a new model, which means your schedule must update whenever dates or durations change due to risks or uncertainties. So what we're saying there is if at each iteration, because of the random nature, picking various values for start, finish time, duration, it could be costs, the schedule basically will expand or contract or shift in each one of these iterations. If that schedule cannot do that, then the schedule will not be valid. The analysis will probably not be valid. So if your schedule is not optimized so that it updates automatically, the results of simulation will be overly optimistic and invalid. So the most important items are eliminating dangling activities. During simulation, if you modify the dates or duration of an activity that are missing predecessors or successors, these changes will not be reflected in the results of the simulation. Hard constraints. These type of constraints, such as must start on or must finish by, block updates to the schedule. You should replace all hard constraints with soft constraints, such as start as soon as possible. In fact, let me say all hard as sort of soft constraints. Probably use at start as soon as possible for all of them, if that's feasible. There are some instances where you do have to have some hard constraints, and we understand that, but you should realize that they will block or stop the full range of outcomes that you might have. There is a scheduled diagnostics, such as a standard 14 DCMA check, that will allow you to quickly identify issues and address them as appropriate. We do have some ways that we can that we will simplify that even a little bit more. So we take the DCMA and simplify it so that it looking at these key issues for schedule quality. Use both risk events and uncertainties. So often when we're discussing running Monte Carlo simulations, we have customers or clients, users who will use risk events or uncertainties, which are 3-point estimates for durations, start and finish times, or costs, but they don't use both. Risk in projects come from the two sources, risk events and uncertainties. Risk events are risks that you will find in a risk register. They're characterized by probability and impacts, cost, schedule, and other ones. Uncertainties are modeled using 3-point estimates. So in terms of if you have a durations of, say, 10 days, you might have a low and a high duration around that. It could be, let's say, 8 and 13 days. While this adds more complexity to the model, there are some tools and processes to minimize the effort without sacrificing accuracy. Uncertainty bands allow you to distinguish levels of uncertainty that automatically calculate estimated ranges based on historical data. And risk events can be efficiently assigned to activities using drag and drop. This eliminates much of the detail work that was previously required when assigning risk events to schedules. Uncertainties in resources and work. Resource allocation is a major driver of risk in project schedules, but it's often overlooked as a source of risk when creating a model for Monte Carlo risk analysis. Applying risk to resources provides an efficient method to broadcast the impact of risk across your schedule and effectively measure the impact of risk on resources and the work in your project. There's ways to optimize the simulation parameters. Monte Carlo simulations can be configured to both improve performance and the usability and quality of the results. Some of these key settings are instant Monte Carlo. This allows you to run instant simulations when you make changes to your model. It's appropriate when you have a smaller schedule and if you make a quick change to a duration, or you change the percentage in a risk or an impact or probability, you can see the update very quickly. It'll happen automatically. On larger schedules, we probably don't want to be trying to do that because of the software will be looking and trying to measure whether it's possible to run a instant Monte Carlo, which in our terms we believe is under 1 second that it'll be able to run that. The setting of the numbers in convergence monitoring, again, more is not always better. Convergence monitoring will stop a simulation once results have converged. That is, they no longer have, and no additional iterations will not statistically change the results in terms of what the mean and your standard deviation are. So this is useful, especially when you're trying to run some quicker simulations. A lot of times people will like to run higher iterations than when it gets converged. You can see 1,000, 2,000, 3,000, 4,000. Those are very good for creating nice looking charts, which are they have more results, so they tend to, the histograms and cumulative probability tend to be a bit smoother and more filled in. And also when you're looking at the very extreme boundary conditions, you may be wanting to run more iterations to make sure that you have enough iterations to account for what's happening at the edges, especially if you have sort of black swan type risk events that have a very, very low probability of occurring, but of high impact. Finally, we can always set setting the high results to match contingency or margin levels, confidence levels. This will simplify the reporting of your results. And then we get to simplified reporting. Before you run your simulations, you want to understand how to interpret the results to develop actionable plans. Monte Carlo simulation provides a variety of visualizations that help you to communicate the results of the analysis to your stakeholders. Charts can be customized for visual appeal, but also provide standard indicators such as contingency or margin lines that are easy to read. Having standard dashboards also help to identify key indicators such as critical risks or crucial tasks, provide easy to understand presentations to your stakeholders. Risk score indicators, such as meters, provide indicators that can be used to emphasize the relative level of project risk and provide a simple mechanism for comparing various projects in your portfolio. So let me switch over to the software. I've preloaded a schedule in here, and we'll sort of work through the various steps so we can optimize this schedule. If we run a quick simulation, this this schedule doesn't have any uncertainties in it. We haven't added, but we did add risks just so we could take a look at how that's set up in the system. When we take a look at the analysis on this, we can see that we can see a base schedule on the duration. Let's say with risks, it's 460 days. So we have about an 8-day, at least at the mean. We have a 460 sort of an 8-day difference. So it's not a lot of risk in the system right now when we're looking at that. But one of the problems that we can have, and we indicated in our system because we recognize that this is an issue for running a Monte Carlo simulation, is we have some hard constraints here. And these hard constraints are blocking the relative level of schedule uncertainty that we should be seeing. So these are, if we look at these, these are must start, I imagine, as I put in there. So we want to be able to remove those. And also, we may have, I've put in here, there's a few ones. This doesn't have, this is should be on our precedent network, but this actually doesn't have, what's happened on here is sort of model a situation where a scheduler has put a must start on here to pin this start date for this new sort of series of activities that will drive off of that. So they've put a must start date on when really it should be coming off of here. It should be driven from this. So it's a sequential task. So instead of hooking it up to the last activity here, which would be 5, so when the rig gets released here, the rig mobilization should hit here, and that will drive that. But right now, any uncertainty that we have in here is not going to affect this one here. So we want to be able to fix that. Now, one of the things we can do is we can run a scheduled diagnostics on that. Now, One of the things is in the schedule diagnostics with the DCMA schedule, it is basically a 14 sort of best practices that you want. The reality, a lot of them we don't actually need to do for Monte Carlo schedule. They're good to do, but they're not absolutely required. So if we want to simplify it, we want to be checking schedule logic, which is right here, up here. So we want to make sure that all the tasks, other than the ones that are at the start and the beginning, it will flag those, but they're not important. The tasks have a predecessor or successor, so that means they will update correctly. And then we also want to be looking at relationships, constraints, and invalid dates. But this one right here, we're going to look at is hard constraints. So we want any hard constraints must start on, must finish on, start no later than. It will flag these so that we can look at, find those ones that are in the system and address those as required. So I've set that up, and we can see those right here, rig mobilization. Now I know that this is missing logic on here because it's got rig mobilization on the first one. It's the starting one, so we're not too worried about that. However, on this one, we'll go back into that. This task does not have successor. This one has hard constraints. We can see these hard constraints. And if we click on those, it will highlight them in the application as we saw. The hard constraints we'll want to get rid of. I know where they are, so we can go in here. So one of the things we want to go in here and go into all of the applications, all of the activities, and put them to as soon as possible. And we need to go up a ways here. So we need to go to the top. I'm not sure why it didn't go all the way to the top. Here we go. There we go. So what we want to do right here is get rid of that and put that as soon as possible. Obviously on a larger schedule. Now we've linked that, so now we want to, and we can start to see that there's some issues there. We'll link that back up. We will remove this one as well. So we'll go into that and remove the hard constraint. And we will remove the hard constraint. We'll just go down as we come through, and we'll do the same here. And we'll get to the bottom. Just put them as soon as possible. And where are we at? Okay. And finally we get to the last one. And that has must finish on. And there we go. And then we can see as we went through there and released it, all of those little red lines, in our application at least, will show red lines to show that there are issues with the schedule logic. Now, just with the risk events that we have in here, that we've added to the system here, if we calculate that, and I've got it set at 2,000 here, just for, and we look at that, and what's actually happened now is we've added, by releasing the precedent network, we've added on another 10 days. So it's actually, we now have a wider range of impacts. One of the things, though, that we are missing, and you can see, and this is very typically what we will see in a analysis where we only have risk events, is all of these, we call them a multimodal type of histograms. This is probably the deterministic chart. We're looking at cost, schedule, cost, duration, and cost, duration, finish time. And these are peaks here just because we're at risk events, but there's not a lot of, let's say, smoothness about them. And that's really because we don't have any uncertainty. And the reality was in any project, we have risk events, major things which cause these major shifts that we can see in the results. It goes from the deterministic risk happens, another risk happens, and here's some risks that are happening way off. So it causes what we call a state change in the project. But there is this natural variance that happens in any project, any activity that we do, not just in projects, anything you do that happens in the world, there's some natural inherent variance. It's called aleatory risk, but what it is that it's the difference between you're driving to the grocery store to pick up, driving to the grocery store, obviously did the shopping. A risk event would be you get a flat tire or you're in an accident. And we could account for that. Run out of gas would be another one. The inherent variances is sort of sometimes there's more traffic, sometimes there's less traffic. There might be more pedestrians going around. The weather conditions might change a little bit. All sorts of things can happen that one day you're able to make the trip in 15 minutes, and the next day it's 20 minutes, and then one day it's 12 minutes. And if you did it 100 times, you'd see that there's this, without a major risk event occurring, you'd still have quite a level of variance, which we could describe as a histogram. That occurs just because of this natural variance that occurs in all of the processes. And if we don't account for that, we're going to miss a large amount of the variance or risk in the system. In most studies that I've seen, it's now looking at around 50-50. Most people say it really depends on the type of projects. The more on the technology development R&D, the higher the relative variance is going to be based on that inherent uncertainty that can't be managed. Takes a hold of that. Other projects where it's a bit more well understood, a lot of times it's the risk events that could occur that will have a higher probable impact on the schedule. But we do want to account for both of them. So one of the ways that we do that is we can calculate. We can create what we call risk bands, and this is the one that's just sort of out of the box. We're looking at one of my. I'm just going to just change these because I don't quite agree with them, and I might have 5. And these are bands, and what happened is if you go back or they might be called reference classes, is if you look over past performance of the projects and what's happened, there are some calculators, some processes that look at past performance or different types of factors within an organization. Their maturity models, what sort of technology is being used, training, all these sorts of things to come into and develop these. And they develop these coefficients or bands that are used to calculate the level of uncertainty based on this information that you have. And it allows you to quickly assign this. And obviously, once you get back into the actual execution of the project, you can start to manually modify these. But when you first set up, it's a nice way to characterize different activities as having a the level of risk they have, and how we're going to calculate that based on the most likely duration. So what's the range of variance that we have that. So we can use these coefficients to apply that to that. So we can set it up here, and we can add, I've seen up to 10 bands. We just have 4 here out of the box. And the way that we could do that, I'm just going to do it very quickly, but if we can grab some activities and we can just assign this. I'm going to do this sort of very randomly. I'll say the gamma ray test is high and the connection is fairly low. And we can start to do that down the, if we think they all have the same type of, did I say critical? Say high, and we'll say low. We're going to do this, and we can just go down and do the same thing down the entire. And what this does, it does a couple of things. One of it obviously allows us to calculate these very quickly. You can see now that as I'm applying this, it's using those coefficients to calculate this based on the uncertainty. You might have noticed that I sort of skewed it to the right, we'll call it, so we have a longer tail to the right. And that's because, if you're wondering, it's because in schedule analysis we can improve a little, but a lot more can go wrong. So typically when we look at the results of any analysis, we do a historical review of similar projects, the results are always on schedule or generally right skewed. And I'm just going to grab the rest, and we'll just say that they're all medium here, just for a second. So then when we calculate that, and we can stop there, we'll take a look at that. We can now see that that uncertainty that's brought on along the risk is actually added quite a bit. So it is actually about 50-50 on here, even though I hadn't determined on. It's added, it's gone from 552 to 5, so it added another 10 days. So it's added almost another 50% onto the uncertainty. Certainly widened it out. You can see how it sort of started to fill in the gaps here, which is a much more realistic way to understand what could happen during the project. We still have that sort of distribution. So this would be the distribution for the original schedule, and then we have a risk events occurring, but they do have some variance that's around those. So by doing this, we're going to have a much more fully realized, and we're going to try and we'll be able to capture all of the risks that could happen in the system from both sources of risk. Now, one of the things is projects have risks, and one of the things is if a lot of times we might have the risk is we're doing a risk analysis, and they'll say, well, one of the risks we've hired a new contractor, and they're they'll be working on it, but we're a bit they're new to the location. There's going to be some logistical issues around that. We want to, and they will affect all of these activities. In that case, and you might go in, well, they might cause a X% delay on all of these activities. You go in, and then you would have to assign this schedule delay or schedule this risk to multiple activities. What you can do with resources, you can actually use that resource and assign that risk directly to that resource, and then it'll get broadcasted out to the whole schedule. So if we looked at that, let's say we have We have this wireline, it's work, and we want to assign a risk to it. Now I can assign if I wanted to, but I'm going to create a now I'm going to say it has a 60% chance of occurring, and we're going to give it a schedule. We're going to say it's going to give a relative delay. Really, all we can, for the most part, is going to be relative delay if it's going to be impacting multiple, and we'll just give it a uniform. Let's say we'll say between 0 and 20%, and that's a uniform distribution. And we'll also say maybe, there we go. So we're going to create a relative delay on that. Based on that, what will happen is this wireline resource risk, instead of assigning a single risk event to multiple activities based on some assumptions or that we have about that particular resource, we're going to assign it to the resource instead, and it will just broadcast and quickly, basically will affect all of the activities that this wireline resource is associated with. And we can see right here, there's the wireline resources here, and here, and here. So by doing that, instead of actually having to assign the risk multiple times, we've assigned it quickly. So it's a nice quick way that if you're able to isolate a risk to a particular resource, instead of assigning it to the activities that the resource is assign it to the resource, and you can then broadcast it out to all of those, and it will affect all of those activities. Again, on a small schedule, not such as this, not such a big deal. But on a larger schedule, obviously can save a lot of time and simplifies your model a lot more, which is one of the things that we want to do, is to try and keep it as simple as possible. The other thing that you can do is when you're assigning risks, instead of a traditional way, might be going into, in our system, is to go in and go into a view such as this, where you're going to assign the risk multiple times to multiple activities, like we do here. You can actually go into what we call a drag and drop risk. So if you do have risk in the system, I'm just going to call it a new risk. And I'm going to assign it to all of the risk mobilization tasks. So I can just quickly go into it. Again, this is just a way that we can simplify and speed up, make our risk assignments more efficient. And then I'm just going to grab that risk and drop it on. It's going to select all of those. We think it's let's just start, said 25% chance, and we'll also give it a, I don't know if we don't have any, we'll give it a cost in here. And let's make that triangular. Just because we can, and we'll do this as well. Not a huge risk, but we'll do it anyways. And we've assigned that to all of those activities, and we can actually see now we've added another risk. We can look on there if we want to look in that activity and see that the new risk is, and these are different risk assignments, we call them. Each assignment has could be whether it's if we call an outcome type, delay, a schedule, or cost. So we have two different ones that we've added there. We can just run that simulation again and see if that's changed anything that how we've ranked it. And that new risk is actually ranked a bit higher than one of our high priority risks now. Now, the next thing we want to do is we're going to take a look at how we can set up the schedule, adds on some of the parameters of the Monte Carlo. In ours, it's on the calculation side. This is what it's not flagged as that, but I talked about the instant Monte Carlo. I've got it deterministic because I don't want it. But if you do have to make small changes, you can run on a small schedule. You can switch just to probabilistic calculation. So anytime you make a change to the schedule, it's going to run a simulation and update it accordingly. There are limits to that. Again, we have an algorithm in place that takes a look at the size of the schedule, how many activities, how many resources, how many risk events, if you have risk events in the system. And it also will then look at your computer and look at the whether you've got how much resources you have available to do the thing, how much RAM you have, and it makes a determination if the schedule's the right size and the and your computer has enough resources, it will enable that instant Monte Carlo. Problem is if you're right at the edges, sometimes it sort of has a little delay, which I don't like. But you can put it on, especially when you're doing if you have a small, 50, 60 activities, and you're looking at a high level one, and you're just doing the initial planning and trying to understand your risks. It allows you to run that and update it quite easily. I'm not sure if this would run on mine right now, so I'll switch that back. I've got this at 2000, just because I like to have these nice, large, filled-in charts for presentation purposes. If I turn this on, this will turn on the convergence monitoring. What's going to happen? It will consider that the simulation has converged if the standard deviation of the duration change is only by less than 0.15 over 20 simulations. And you can play with this a bit if you want. At the default settings, we find that most schedules, regardless of their size, are going to converge between 350 and 600 iterations. They will converge at them. So this will actually probably push it out to that maybe up to about 700 or 800. We can see if we run a quick test on this. The other side of this is also when we set that, this right here allows us to set, I think the wording is a bit strange, but when we look at the results, there obviously is a range that you'll see in a histogram and the cumulative probability, but we also have low, medium, we have low, base, and high. And what this does, it allows us to set what low, base, and high is. And this is the default. Now, what I'd like to do, and so this allows me is to set the high value, the P value here, as the one that we're going to be used to be generating schedule margin and cost contingency. So level of certainty that's around there. And P80 is very, very standard within this type of analysis. It seems to be a relative, enough risk tolerance, takes into account some risk taking without and being conservative enough to have a high enough certainty. We're talking about 8 out of 10 times, which would be fairly. If you look at projects, if you had a track record of meeting schedule and cost, 8 out of 10 times would be considered quite good. The more risk taking you might have, more risk tolerant you become, or You might, down to 70 I've seen. You could put it down to 50 if you wanted. But again, we're just going to use that because it also allows us to set markers when we look at the results of the simulation. Now, because I've changed those, it's going to ask me to set that. So the last thing, we'll just run a quick simulation. Let's see what happens. Oh, that actually changed it quite a bit. So it went up to 1200 there with those changes to that. Now, the last thing is that we want to be able to set up our visualizations so that they provide a bit more information, simplify that. As they're set up right now, they don't provide us a lot of information. And we can sort of look across. If you've been doing this as long as I have, it actually tells me. But if you want to have a quick presentation report or senior management, I want to be able to see something and grasp that information very quickly. We want to be able to modify these as quickly as possible, or modify these so the information is communicated as quickly as possible. So we can take a look at this cost chart and what can we do about that. So this is the detailed view of the cost chart that we have in the system that can be obviously exported out in reports, etc. We're going to add a little bit more information to it. And we can do that by going to options. Now, what I want to do on here is I want to add the cumulative probability to that as well. So we have that S curve that appears on it. What I like to do is and this is just purely a visualization thing. I like to change the bar width. I like to make my bar width a bit wider and create a little gap in there. Now, we have all these lines that we can draw on here, and you can see that I'm not going to put the P30 on there because I'm not sure that I want it to be on there. Yeah, it shows the deterministic. We can turn that on or off. And I've got that P80. Now, one of the things, too, is that it has the values there. It doesn't actually show so well, but it's the... And we can make sure that these appear on the smaller charts. We can play with the colors a bit. A lot of times you might want to, if you're at the, on this slider we have here, the color can change. If you want to do it interactively, you can change that as well. And we get a chart similar. Let's go back in. I don't think it's showing. That's okay. Sorry, I'm just looking at something here. Okay. And you can do the same. This sort of gives us a bigger view. I think it's cleaned it up quite a bit. If you have the software open, you want to show that. We show the deterministic. This is our most likely. We can drag that across. If we drag this across to the P80, we can see this right here, and it's get the difference, and obviously the difference between the here and here. If we wanted to, we could highlight that. But it does give some markers that just communicate, again, the level of risk, the difference where the P80, where this is your mean on the chart, and where you're deterministic. We can open that up and show it on here. And we can do that if we wanted to. We could do that with all of the other charts as well. And again, what it does is it gives us a quick view. The other side of that is when we're looking at a dashboard like this, again, we can see this. It says high, but we know it's P80, so we can pull these values out within any of the visualizations. It will give us the values. The difference between this is our P80. Here's our base, which is our mean, and here's our deterministic. Current schedule is our deterministic. At the P80 right now, the difference between our current schedule, we have about 1.4 million dollars that we would need to have in cost contingency or cost contingency. The other thing that we have here is a sort of level of we have these meters up here on the dashboard, and we can just seeing if I can get that. I have a thing out of the way. Is that we can change what this means, but this is how it's calculated. It's the mean plus the standard deviation over the deterministic value. And then we can change actually how the charts themselves work in terms of the range of values. I like to set it at 2 when I go out again. And what this does here is when we're looking at it, it tells us, gives us a value of what these are, the relative amount of cost and schedule risk for this project. So it gives us, again, when we have this sort of data, we can actually see how much relative risk you have across various projects in your company, and allows us again to do some comparison about where your risk lies and the relative amount of risk that lies in your company. The other report that we like to look at is the other dashboard that we have right out of the box is the 3x3 project dashboard, which has the same meters at the top, risk meters. But if we look at this, it also gives us this quick, again, as terms of framework, we can print these things out as a dashboard. And what it does is it tells us what the total project cost is with and without risk. With and without risk, with the risk here is at the mean, not at the P80, but it shows us our mean outcome for project cost, finish time, and duration, so we can see the difference there. It also tells us what are the most crucial tasks, so which are the main drivers. So this is what you might call a very, very simple sensitivity analysis. We do have more in-depth sensitivity analysis, but this provides a quick, again, way to communicate where your main drivers are in terms of activities. And these are also your 3 most critical risks based on the simulation for risks that affect project costs, risks that affect project duration, and risks that affect all the parameters. So the risks that have the most impact across all of the taking into account all of the impacts that you have, cost and schedule. So with that, that ends my webinar for today. If you do have any questions, please feel free to ask them right now. Actually, I do see a few, but I'll see if I can't get to them. It seems to be blocked out right now. As we said, the webinar is being recorded, and if you do have any, if you do want to look at it later, it'll be up on our website within the next 48 hours. I'm just going to have a few questions. So we have one right here. Using first question, using Primavera P6, will you have the same level as integration as MSP, or will you need XML import export? With version 7.1 that's coming out in the next month or two, we will have full XER support. We got it actually in our builds right now. And could you give some typical example of a risk associated to a resource? So a risk associated with a resource would typically be unavailability. So with that, we know that we have, in a lot of cases, you're going to have, as it's from Philippe Gastonel, is that a lot of times the resources will have certain characteristics. One of them that they might be working on multiple projects, key resource or critical resources working across multiple projects at one time, and there's going to be an availability issue with that, or availability risk. And so if you believe that that risk is that resource is going to have limit or is going to cause access to that resource, is going to cause delays, you can assign that delay type risk to the resource rather than the activities that the risk is associated with. So currently you would be able to export a risk-adjusted schedule to Primavera P6 using an XML file and turn it into a performance. And you could export that out at any particular level of the system. So when let me just go back to the application. So once we run a simulation, let's go back to schedule. I think we've run the simulation. That'll be enough. You can actually go in and then export it back as XML. And it should I don't know what type. Oh, so it just has some issues with how I'm. And then so you probably didn't see that, but it opened up because I've just got the webinar focused on the particular, and you can then export that out as the default ones are low, base, or high results. So that would be whatever you had in those settings that we looked at. So right now it's P80, or I could set them out and put the results based as some other level of percentage. So if there, okay. So if there's any additional questions, and there doesn't appear to be any more, I will we'll finish up the webinar now. Again, if you're interested, here's my contact details are on the slides. If you'd like to have the deck, we can make that available as possible as well. And again, we do have a lot of resources on our on our website in regards to this type of analysis, as well as anything else in regards to Monte Carlo simulation and risk management. Again, thank you very much, and if you do have any questions, please feel free to contact me at my email, mtrumper@intabor.com.